We present our ICCV submission, EgoLoc, revisiting 3D object localization from egocentric videos with visual queries. Recent advancements in 3D understanding and video understanding fueled the interest of the community to investigate 4D understanding, or 3D plus time understanding. The Ego 4D dataset is a recent huge effort in this direction. 3,600 hours of egocentric videos from 74 locations across the globe were collected and include variety of annotations. The VQ3D task in Ego4D, or visual query with 3D localization, is about giving a egocentric video clip and an image crop depicting a visual query object. The goal is to localize the last time a query object was seen in the video and return the 3D displacement vector of that object in that frame. The current baseline naively left the VQ 2D predictions to 3D predictions without regard to the difference in the domains and reference coordinates. Our contributions are threefold. We formalize the pipeline for the task of VQ3D and elevate the baseline performance from 8.7% to 77.3%. We propose to aggregate multi-view 3D displacements by employing the 2D detection confidence to weight predictions and further enhance the 3D localization. Our method EgoLoc achieves an overall success of 87% in the test set of VQ3D task. We conduct extensive empirical analysis of different components and configurations of the VQ3D pipeline. This is an overall pipeline in EgoLoc, consisting of pose module, detection module, and multi-view aggregation module. In the pose module, we collect camera poses with call map for all the frames in the VQ3D sequences and re-register these frames to the query frame poses obtained in the original VQ3D data. This leads to robust and correct reference poses for all the video sequences and frames. This is necessary for later parts of the pipeline. We run in the detection module 2D detection network used in the VQ2D training on the same data to obtain object proposals with similarity scores for all the frames, and most importantly, the query frames that we need to predict the 3D displacement for. The detection Siamese architectures give different proposals with different similarity scores. We pick the peaks temporally based on some threshold, resulting in multiple 2D boxes with scores spread across the video frames. Our multi-view module uses 3D poses and depth estimated from every frame of the peak frames of the detection module and their similarity scores and box centers to do weighted averaging and predict 3D displacement based on the 2D confidence of these detection module for each view. The Ego 4D VQ3D benchmark has 164 training video, 44 eval validation video, and 69 test videos. The visual queries are 164 in the validation set and 264 in the test set. The metric used are the angle difference, the query with poses, the L2, success on posed images, and overall success. This follows exactly from the Ego 4D paper and illustrated in this figure and explained further in the paper. The improved pipeline raised the baseline performance by almost 70% in the test set, and our EgoLoc get an overall performance of 87.12% in test set. This test set has no open labels available and only available through test server. This sets a new state-of-the-art results for the VQ3D task. Here we show some qualitative comparisons in 2D and 3D and visualize the 3D predictions and ground truth for our method and the naive Ego 4D baseline. Here we show more qualitative results of our method in 3D and with queries mentioned below each image. Here we compare different detection ablations and their effect on VQ3D performance. Using the last VQ2D track versus last detection peak versus top peak average pooling, and eventually our EgoLoc, which weight average the detection predictions for different frames of the video. Here we applied the multi-view aggregation method compared to a single last view or mean average or NMS averaging, and our Ego weighted average of top peaks views. Here we show the effect of peak window size on the success and L2 performance of EgoLoc, indicating that if more views are used in our multi-view aggregation, the better, which utilize more information from the egocentric video. Thank you.